In this tutorial video, we will go through the example of the container ship and learn about using ArrayList inside another class. So in this example, we have two classes, one that models a ship and the other one that models a container. So those two classes kind of take care of storing information about containers and ships carrying these containers. So we can think about these classes being put in use in an application, for instance, used by a customs agency or a port of entry to represent data, to store data information and process information about ships, containers, goods, and services passing through this port. Now, we have provided some code, including a class container. A container has two attributes, weight and content. There is a constructor that sets these attributes and two getter methods. The class ship represents a ship, has four attributes: name, empty weight, and total weight. In addition, it has an array list of container called containers. So when a class has a collection of another class, this is used to represent a one-to-many relationship. This links one instance of the class ship to many instances of the class container. So the class ship has a constructor that sets the name and weight. Of course, when the ship object is created, that weight, the empty weight, will be the total weight of the ship, and this will change once new containers are added to that ship. A couple of getter methods: get total weight, empty weight, get name. And there is one method called report, and this method basically formats the ship object and prints it out to the standard output, printing name, empty weight, total weight, and also goes over each container in the array list and print the container content space and container weight. Another method, getter method, is get number of containers, that returns the number of containers in the array list, and also a method get container that returns a specific container at location I. So based on this initial implementation, there are a couple of tasks we would like to work on to further improve this class. First, we would like to implement two methods, add container and remove container, to add and remove containers from the array list in the class ship. The way this class is used, for instance, is once the new object from the class ship is created, if we have container objects, then we can pass these objects as parameters to the method add container, and this is supposed to add these containers to the array list. So when the ship reports, we should see the content of these containers as well as the total weight of the ship reflecting the weight of the containers on the ship. Of course, these methods don't do anything right now, so if we run this code, you will notice that it only prints the ship name and the empty weight, which is the total weight. Okay, so the first step is to work on the method add container and remove container in order to add the container object to the array list in the class ship. So the method add container, we basically want to take this object C and add it to the array list. So the method is add, and the object we're calling this method on is containers, which is the attribute, and the method add C. Now we need to do something more than just adding this C to the array list, because once we add a container to the ship, we want to adjust the weight of the ship, right? The total weight of the ship should reflect the weight of the containers on board. So what we do here, we just take the weight of that container and add it to the weight of the ship. So what we do, container weight will be the weight of the container. We access that by calling on the method getWeight. It's a double. And then we add this container weight to total weight. Okay, so those two things. And if we run the main method again, you can see that now the containers are added to the array list, so they show up when the ship reports, but also the weight reflects the weight of these two containers. Now similarly, we want to do the same for remove container. We want to take the container at location I and remove it. So we can call the method remove and pass I to that. But then we need to do the same. We want to adjust the weight of the container. We want to take out that weight of that container from the total weight of the ship. So then the question is, what is C here? How do we get a hold on the container that we removed? Well, there are two ways to do that. We can either get that object before removing it, so we can do containers.getI, and then remove it. But now because we have a reference to that object, we can access its weight by calling on getWeight method, and then we remove it. The order is important here because once you remove it, it's gone. If you do get I, you will get a different object. Or the method remove actually returns the object that was removed. So we can store it in a local variable here, container C, and then we use this local variable to get weight and adjust the weight, the total weight of the ship. Well, let's now go back to the main method and call on remove container 0, which is the first container, the text box, and see what we've got here. Right, so you can see that the first container is gone and the total weight of the ship is adjusted. All right, so those are the two methods, but we have some extra tasks to work on. Now, whenever we're working with a collection like an array list, we would like to verify that the input we are getting is valid before processing it. And these methods, there are many opportunities that the parameter may result in an error. The most likely error is an index out of bound, and this is basically when the index exceeds the size of the array list. So what we would like to do, we would like to safeguard the method remove container and also get container by double checking that the index is valid before processing or operating on it. So that's the first task. So let's go back to the class ship here. Well, before, let's see how this error may arise. Let's say you want to remove container 10 and there are only two. We will get that index out of bound exception. So what I'm going to do here, I'm going to take a look at these methods. Both of them are there are two methods that accept an integer parameter. So what we can do here, we can do something like if I is more equal to 0 and I is less than containers dot size, we can basically return container dot get I. Otherwise, this is an opportunity to print line an error message. Okay, and of course this method has to return a container object. Well, invalid index, we can then return null just to indicate that nothing has been returned with this index here. Similarly, we can do the same for remove container. We can use the same if statement here before proceeding to remove. And again, this is an opportunity to print an error message. Valid container index. And since this method is void, we're not bound to return anything, so there is no need to return or to hit a return statement here. If we go to this example here, we write an invalid index, we'll get an error message invalid container index and nothing will change. Alright, so encapsulating the array list as an attribute of another class, protecting it as a private attribute, allows us to take control over how it's accessed and also do some verification checks to ensure the quality and integrity of the data before changing it. Now, move on to the second two task. It's asking us to create two methods, getContainer and getContainers. Both of them accept a string and search for a container that matches that string. So it's like a keyword search. You're searching for a container that contains a keyword that matches the keyword of the search. The difference is that getContainer will return the first container matching that parameter, whereas getContainers will return all of the containers matching that parameter. So in the class ship, we have two method stubs here for getContainer and getContainers. They don't do anything right now. They all both return null. So let's get and work on them. So what we want to do, we want to go over each container in the array list. So we can use a for each loop since we're processing each one of them. For each container seeing containers, then we would like to look for the content of that container. So that's c.getContent. Now, what we also want this search to be case insensitive. So what I'm going to do, I'm going to convert it to lowercase. Of course, this is incorrect because we already have a variable called content. So I'm going to change this one to keyword. And what I'm going to do, I'm going to check if content contains keyword, and I want to change keyword to lowercase as well, so that both of them have the same casing, hence the match is case insensitive. If this is the case, I want to return C. And this is the first container. Once you hit return, the method finishes its execution. If you exhaust all containers and we don't find anything, we return null. So going back to example here, maybe example 5, we have a bunch of containers, textbooks, workstations, beans, and books. We're adding them, and we would like to print ship.getContainer. Let's actually just do this for now. GetContainer Java, for instance. And of course, we will get one container. If we print ship.getContainer book, we will get two containers containing book, textbooks, and books. There's no container containing car, so we will get null here. Let's run. So we get one contain two of course, we're getting the first container, so this is the first container containing Java, which is Java textbooks. And the same container is the first container containing the keyword book. Hence, we've got the same container object, which is formatted as a class name at memory location. The third one will return a null. Okay, so now let's move on and finish the second method, which is the method getContainers. And this one, if we take a look at its specification, it actually takes one parameter of type string, keyword. Actually, this one we need to update the documentation to keyword. And returns an array list of containers, right? Null if none found. So what we need to do, we need to go over the array list, but instead of just returning the very first object we find, we need to store it in its own array list, and we return this array list. So what we're going to do, we're going to create an array list, a second array list called matches. So you can think about this array list as a subset of containers, right? Because you've got one big array list here containing all of the containers, and we're only interested in one subset, one of these containers that contain or match the specified provided keyword. So this is a brand new array list. What we're going to do, we're basically going to do the same. We're going to go over each container in containers and do the match. Now, if there is a match, instead of returning, we need to add C to matches. And we're basically doing this because we want to keep track of all of these matches. Once we are outside of that loop, at the end of the method, we return matches. And this works perfectly fine if there is at least one match. You will get an array list containing the match or the matches if there are more than one match. But this method says null if none found. Well, this one, if none found, it will return an empty array list rather than null. So just to abide by the specification of this method, I'm going to test whether there were any matches by looking at the size of this array list. If it's more than 0, hence there's at least one match, return matches. Otherwise, we return null, just to ensure that we are implementing the specification here. Okay, so now let's go back to the example here. Right now, we are interested in all containers containing the keyword Java, book, or car. So you've got 2 containers containing Java, 2 containing books, and none containing cars. So if we run, you can see we get the list of containers 2, 2. And one of them is common, right? This is Java textbooks, that the content contains both keywords, Java and textbooks. And null for the car keyword because no container contains car as inside the content. Alright, so now you take a look at this output. It's not very meaningful because the object is formatted as object class name at memory location, which is the default way Java formats objects when they're printed or when they're converted to string. So what we want to do now, we want to improve this by providing a toString implementation in the class container, and we can also do it in the class ship. Okay, so the container is formatted as content space weight. If this is how we want to format our containers, we can provide a method toString, and then we can implement this as content space weight. And this is how the container object will self-format. Let's redo this run, and you can see that these container objects formatted properly now. Now, more than that, in the class ship here, when we are going over each of the containers in the method report, we no longer need to do this. This is kind of redundant because this is basically how the container object formats itself. So if you want to have the standard format, there is no need to do anything. We can do system out println C, and if you do ship report now, that will work just fine because when you print the container object, it will call the toString method and self-format. Okay, so of course this is calling the method ship, but if you do something like system.out.println ship, we will get the same object class name at memory location because the class ship doesn't have a toString method. So let's provide it. It's basically very similar to what report is doing, but the toString method, instead of immediately printing, it will return the printout as a string. So what I'm going to do here, I'm going to say, let me start with the string output, which is what I want to return at the end of this method. And then the string out should contain all of these lines. Should contain first this header line with a line feed /n to hit an enter, and then the string out should contain the ship name plus name plus /n. Okay, and then the remaining lines as well. So plus empty wait plus slash n. It's actually a backslash, excuse me. So total wait plus backslash n. And then now we want to get the containers on the ship. So that's that, backslash n. For each one of them, we would like to add the container. So what do? That's the same for each loop. Instead of printing, we do c plus backslash n. And of course, if you add c, the method toString will be called indirectly. And then finally, we want to have that footer here at the end with backslash n. And then we return out. So now if we go back to 5 and we run, you can see that the ship is self-reporting here. Okay. Well, I think for this one we don't need to provide the backslash n because this one will be passed forward to println. So just to keep it exactly like report. Okay. So now whenever we do system.println and we provide a ship object, the ship will self-format. And of course, now this code is redundant. So instead of doing all of this, we can do system.out.println toString. So basically converting this object to a string. If you insist on having the object name, it's this because we are reporting on this on the same instance. So now if we run example 4, which has been calling the method report, it still works as it used to. All right, so this is providing the method toString implementation in report. And this concludes this tutorial.